Let's go back to analysis 1. Here you see I will do again in this step. Actually, what I need is the stalk and the angle. Here you can see the stalk in here, but actually I don't need to select again in the maxima and minima, because the stalk has includes the maxima and minima already, and angle also. So I just select these two items to make wrong. Okay, here you see this one's angle. The minimum is around 11 degrees. The maximum is around 19 degrees. Later I will use a formulation to average it. Very simple average. Use the maximum value and the minimum value, I plus them together to divide into sec 2. I guess around here, 15 or 16. But the first important is to make the stalk longer, to be 200 millimeter. Okay. So here you can see the parameters maximum and minimum. Maximum and minimum here. So close them, and here you select yes. You have to in here you have to remember this parameter name, because we need last video I said I need to use this name in this relations formula. Relations are formulation. Okay. Minimum angle, maximum angle. I think very easy to remember it. And okay. Here the next analysis I select relation, and here is next. Here you can see the third one is STROK stock. The stock MAX. That's what. Yeah. FID. Here is the let's say target and angle A. Okay, enter here. Here I use max NGLE FID and in here you follow my step to build up the to draw up the formulation. Later I will describe its meaning. Here stock I think you know is the distance. Maxima the minima, you make a difference. Okay, and here you have to keep remembering FID is one. It's a system to catch up NS one's parameters name, and the system will get known its physical value. Okay, here divide 2. The second row, as you see, I told you use a maxima and minima and plus together. Then I divide them in 2. Okay, so it's around, the maximum is around 19, minimum 11. I think it's around 15. So yeah, I click okay. System will automatic to compute, I think so. Okay, as you see, system compute the result. The next step is to do the sensitive analysis. Here you see, because there are 4 items. Is a viable design. So what does it mean? It means I can use a dynamic dimension or parameter to set up it, and it can affect the structure and make it to be our requirement. What does it mean? It's long description, sorry, because as you see, if I change the crank length or the rod 1 length in this range, the stock might be changed also. So because we want the design constraints 200 in our target, so we use this viable design to make it. However, we cannot use the manual method to do. You can't change 1 by 1 from 15.1 to 90, or from 161 to 190. It's waste time, or it's not efficiency. So here I use a PROE computer to calculate its result. In this sensitive this windows, we can observe every parameters relation with the target. For example, in here I can select the crank, and every time you can just select only one. Okay, crank. The range is 50 to 90. Okay, 50 to 90, and the target is stock, right? Stock. So we compute it. As you see, the from 50 to 90 in here, you will go down first and then go up until 30, and it stops, or not stop, it remain on the 30. Okay, so here you select the rod 1, compute. Sorry, I have to stop it. I'll stop it because I need to set the 160 to 190. 160, 190. Okay, compute. So before you do the mechanism analysis, you have to clarify every parameters and your target. So here I can observe it's sensitive plot. To check if it has any matters on it, it will convergency or not. It will be convergency or not. Okay, so drop to 180 to oh. The rod 2 is here over 200. So the next one was 3. Oh, sorry. So yeah, I think I stopped here. So we loop back to the 4 parameters. The last one we check the compute result. Oh, sorry, I have to. 290 to 320. So the rostry cannot reach the 200. You see here? So only crank and crank. He cannot reach also. Sorry, because I didn't modify the under. However, you don't care about this sensitive plot, this graphic. You can use this one, feasible optimization window. Here you input the stroke is we hope 200. Okay, and the 8 parameter crank rod 2A, rod 3, and make a check 50 to 90. 50 to 90. More parameters you need more time to do. So if it's a complicated case, you should use the sensitive analysis previously to correct which one is necessary to do the feasible analysis. Not 2, okay. 2. Not 2 is here I still keep the 4 parameter to compute each result. I don't care about the computer's my computer's efficiency in calculation. How you can compute. I guess you need a longer time to do. Okay, you see, a feasible solution has been successfully found. Close. The model has changed as a result of optimization. Please confirm. Okay, I confirm it. So you can see the parameters here. Next, over 200, right? However, the target is not yet. The target inner is not yet. So the next procedure, I will show you how to optimize the angle. So here I finish this step of video. Thank you.